Hi, so today I got a question, or rather two questions about very similar thing on our Discord in XState. And the question was like how to type properly state values. So basically we in XState we have state machines that have some certain states that are represented by keys, and in here we can, for example, let's grab initial state and try matches, so we can check if the machine at the moment in a given state matches the particular state. And the problem is that we use the so-called type gen to inject some extra information and that information is like statically analyzed, and we inject that into your create machine calls. The real thing is kind of like bigger than that, but this is a slimmed down version that only has this matches states. And the point is that we are actually using this matches states to type properly this machine or other state matches call. So yeah, this A and B is driven by this type gen 0 from here. And the problem is that since this is injected, the user in here didn't want to rely on the type gen, because like usually it's even imported from external file and it's dependent on the file name and that we are currently editing. So yeah, like reaching for this type is not the best thing because it can easily break, and yeah, that the user has wanted to avoid that. We can just like confirm that this one actually works, like we have A and B. So yeah, like providing another value results in an error. If I put an A, it just works. And the other user had a more like complex situation a little bit, but basically it boiled down to the very same thing. He wanted to provide a type in his own like function signature for the very same thing. So like for the type for those state values, and he managed to do that. The problem is that he has managed to do that using our sort of like an internal type. We can see that it's prefixed with like two underscores. So it is really meant to be a private type, and it's not meant for the public usage, mainly because like we can't guarantee a stable shape of the type that is returned by this helper. It works here in the very same way. Like this function actually accepts two arguments, but that's really not that relevant. We have autocomplete and all of that. Yeah, so we can actually try to refactor that, and let's try to do that. So I have the same function and the same setup here, and one of the things that I would like to avoid first is to remove this target. I believe that we should strive to minimize like how many generics we accept, and the point is not even like that we should minimize them, but like what is generic here? The point of generics is to allow you to like provide a subtype for a given thing, and actually like what we accept here at this position is always or at least like in my opinion, it should always be bound to the interpreter itself. So it should act as a source of truth for the second parameter, and we don't have to accept a generic here. Like it's a little bit pointless, and we don't want to restrict ourselves here anyhow. So yeah, like we can just drop it. But yeah, right now we need to type this target. So how can we do that? Like my first intuition is to to basically reuse the type of the state and its method, its matches, and just extract the first argument from it. So let's try that. We can just create this this test type. Let's grab state from type of machine, and we can see that we have the matches, and it has a type. We see it here, and we can just grab its parameters because it's a function, so it will like be satisfied. Here it will satisfy the parameters type, and we grab the first parameter. Unfortunately, we get never in return. And why is that? The problem with conditional types usually is that they only return the very last overload, and it happens so that matches is actually typed using overloads. We can see them both here. We have this single overload that is that is meant for like machines with a type gen, and the second overload that is meant for machines without it. To avoid some breaking changes and to satisfy some constraints, we at the moment had to use it like this. Like we had to. It was way easier to just use those overloads here. We plan to remove that in the future, but at the moment, like it doesn't even matter for this exercise here because you can deal with functions that have overloads. But yeah, we have problem with that conditional type. We can't really use return type on it. So what we can do, it actually turns out that we can actually infer from overloads. It's just something that is rarely done, and I have actually learned that from Devansh. Yeah, so let's try that. Type gen argument and type gen enabled argument, type gen disabled argument. Maybe like type it using an interface. State value, type gen enabled arg, and we don't care about the return type here, so let's just type it as any. That's not the one we need. Yeah, so like I just provide slots for those positions here. I am a little bit like bound to how many overloads this particular function actually accepts, so it's not like it's some kind of a universal solution, at least not here. But I'm also like wanting to deal with this specific situation, so so this absolutely works for me. So yeah, let's try using that, and we can do something like this. We can basically like call the state from a machine, grab this type, and now try to match it against that interface with overloads. So I'm actually interested only in the first one. Yeah, like this one, and some placeholder here. So yeah, we need a fallback here, and in here we can just grab that one. And we can see that it actually works. It's a little bit magical. I have only learned about that not that long time ago, that you can actually like infer from from overloads, and it's quite awesome, and especially like for the issue at hand. So maybe like just wrap it in some kind of an alias, so it's easier to use it. T machine extends any state machine, and let's replace that with T machine. And now we can actually actually just use this type here, but we still need to provide a machine to it. So let's grab it from the interpreter type. And yeah, I think that's pretty much it. We can just recheck if everything works correctly. And we have autocomplete, this stuff, errors on the incorrect values, and all that jazz.